Imagine crossing the finish line of a marathon, feeling like your legs are on fire, only to discover that the worst damage is yet to come 72 hours later. Marathon runners know the dreaded feeling of crossing the finish line, only to be hit with excruciating pain in their quads, making every step feel like a chore. But what if I told you that this pain is just the beginning? A 2015 study on 22 Chicago marathon runners revealed that the enzyme creatine kinase, a marker of muscle damage, peaks 50 times higher than normal on day 1, only to keep climbing for 2 more days, with the worst damage occurring 72 hours after the last step. The study's design was straightforward. Researchers collected blood samples from 22 experienced marathoners at baseline, 24, 48, and 72 hours post-race. They tracked creatine kinase, myoglobin, and inflammatory markers with lab precision. The runners' average finish time was 3 hours 45 minutes, indicating they weren't elite athletes pushing physiological extremes, but well-trained amateurs. This matters because it shows that the delayed peak in muscle damage is the standard timeline for human muscle after prolonged eccentric loading. Let's break it down. Every foot strike during a marathon forces your quadriceps to lengthen under load, causing mechanical stress that disrupts the contractile units inside each fiber. The damage is immediate, but the enzyme leakage we measure as creatine kinase is a secondary cascade that unfolds over days. At 24 hours post-race, the runners' creatine kinase levels averaged around 10,000 units per liter, a 50-fold spike. But here's the critical part. The membrane damage from race day has opened channels, and the real enzymatic floodgate hasn't opened yet. The pain peaks early because nerve endings respond to mechanical distortion and acute inflammation. But creatine kinase release requires complete membrane failure and protein diffusion out of the fiber, which accelerates when immune cells invade. These cells don't arrive in force until 24 to 48 hours post-injury, releasing proteases and reactive oxygen species that finish what the mechanical stress started. The hurt you feel on day 1 is just the beginning. The damage you measure on day 3 is the true extent of the damage. By 48 hours, the study's runners showed creatine kinase climbing toward 20,000 units per liter, double the day 1 values. Subjectively, many reported feeling better, but the biochemical trajectory tells a different story. Membrane permeability is increasing, not decreasing. The immune infiltrate has peaked, and proteases are dismantling contractile proteins. Myoglobin has already cleared the bloodstream, which is why urine color normalizes while CK keeps rising. The disconnect between symptom and pathology is widest right here. 72 hours marks the true peak of muscle protein leakage, with average creatine kinase hitting 30,000 units per liter, 3 times the day 1 value, and 150 times baseline. This is the moment when the last compromised membranes finally rupture under cumulative enzymatic assault. After this, clearance exceeds release, and the curve crashes. Satellite cells, the stem cells of skeletal muscle, are activated, proliferate, and fuse to damaged segments, donating new nuclei and initiating repair. The repair window has a strict biological timetable. Satellite cell fusion peaks around day 4 to 5, new contractile proteins incorporate by day 7, and full structural restoration takes 10 to 14 days for moderate damage. But the signaling cascade starts with the day 3 inflammatory peak. Researchers who biopsied marathoners' vastus lateralis at 72 hours found macrophage phenotype switching from pro-inflammatory to reparative, happening precisely when CK peaked. This changes everything we thought we knew about recovery. Ice baths, once thought to be the answer to post-marathon soreness, may actually blunt satellite cell activation and delay strength recovery. The mechanism: cold vasoconstriction limits neutrophil infiltration, reducing protease release and CK peak, but also reducing the growth factor signal that wakes satellite cells. You feel better faster, but you rebuild slower. Inflammation is not the enemy, it's the construction crew. The day 3 CK peak correlates with interleukin-6 levels that peak at the same time, signaling satellite cells, recruiting macrophages, and stimulating hepatic glucose production for repair energy. Suppressing the peak with aggressive recovery might blunt not just local repair but whole body remodeling. Individual variation in the 2015 cohort was staggering, with the lowest day 3 CK at 4, 500 and the highest at 112,000. Same race, same distance, similar training. The difference? Genetics. Polymorphisms in the actin-3 gene explain 30% of CK variance. Runners with the Roman 20 genotype had 40% higher peaks. Collagen type variants affect extracellular matrix stiffness, and even vitamin D status correlated with clearance rate. Clinical context matters. Creatine kinase above 50,000 carries rhabdomyolysis risk, and myoglobin can clog renal tubules. None of the runners reached clinical rhabdomyolysis, but 2 brushed the threshold. Day 3 is also when compartment syndrome risk peaks if swelling compromises facial compartments. The biochemical peak coincides with maximal edema, which is why the study scheduled day 3 blood draws alongside compartment pressure checks. Practical translation: don't judge recovery by day 2 feelings. The runners who felt fine at 48 hours and resumed training often regressed. The study's follow-up showed strength deficit persisted until day 7, despite subjective recovery by day 3. The optimal window for aggressive reloading: day 5 to 7, when satellite cell fusion peaks and new sarcomeres are integrating. Light movement from day 1 accelerates clearance by increasing lymphatic flow, but loading damaged fibers before day 5 risks re-injury. The 72-hour peak isn't a finish line, it's the starting gun for the real repair race. Muscle isn't just a motor, it's an endocrine organ. The day 3 CK peak releases not just enzymes, but microRNAs, exosomes, and metabolomes that signal liver, fat, bone, and brain. Marathoners' post-race blood shows elevated BDNF, irisin, and FGF21, all muscle-derived factors that regulate metabolism, cognition, and bone density. First, the mechanical tier, then the inflammatory invasion, then the enzymatic peak at 72 hours, then the satellite cell fusion, then the new sarcomeres. The 2015 Chicago Marathon study didn't discover a flaw in human design, it revealed the timeline of a feature. The 3-day delay isn't a mistake, it's the mandatory interval between demolition and construction. Your legs bled muscle for 3 days straight because rebuilding requires the rubble to settle first. The pain lied, the enzymes told the truth, and the truth is that you're not broken at the finish line, you're just beginning the part that matters. Practical translation: don't judge recovery by day 2 feelings. The runners who felt fine at 48 hours and resumed training often regressed. The study's follow-up showed strength deficit persisted until day 7, despite subjective recovery by day 3. The optimal window for aggressive reloading? Day 5 to 7, when satellite cell fusion peaks and new sarcomeres are integrating. Light movement, walking, cycling from day 1 onward accelerates clearance by increasing lymphatic flow, but loading damaged fibers before day 5 risks re-injury. The 72-hour peak isn't a finish line, it's the starting gun for the real repair race. Muscle isn't just a motor, it's an endocrine organ. The day 3 CK peak releases not just enzymes, but microRNAs, exosomes, and metabolomes that signal liver, fat, bone, and brain. Marathoners' post-race blood shows elevated BDNF, irisin, and FGF21, all muscle-derived factors that regulate metabolism, cognition, and bone density. The same damage cascade that leaks CK also broadcasts systemic adaptation signals. Suppressing the peak with aggressive recovery might blunt not just local repair, but whole body remodeling. The 2015 runners' day 3 blood wasn't just a damage report. It was a progress report on systemic upgrading. First, the mechanical tier, then the inflammatory invasion, then the enzymatic peak at 72 hours, then the satellite cell fusion, then the new sarcomeres. The 2015 Chicago Marathon study didn't discover a flaw in human design. It revealed the timeline of a feature. The 3-day delay isn't a mistake, it's the mandatory interval between demolition and construction. Your legs bled muscle for 3 days straight because rebuilding requires the rubble to settle first. The pain lied. The enzymes told the truth, And the truth is that you're not broken at the finish line. You're just beginning the part that matters. The next time your legs scream on day one, remember, the real work hasn't even started yet.